Okay, the first part of this lesson about law of sines and cosines, we looked at two angles and one side. And that's law of sines. And that's probably the easiest kind of triangle to solve. Now we're going to look at, how about if we have one angle and two sides? And now here, it actually matters which angle and which two sides. Now here's how I break it up. And I'll explain this in a minute. You may have a situation where I call matching and the other situation is called non-matching. So they give you an example. Matching would be, say you're given a triangle and they say side A is a length of 3, side B is a length of 2, and angle A is 50 degrees. So once again, we're given three parts of a triangle. In this case, we're given two sides and one angle. But by matching, here's what I mean. One of the sides and the angle are like the same letter. Non-matching would be like this. Later on, we're going to do this problem. They give us side B is, they give us side A is 2. Side C is 4. And they say angle B is 45 degrees. So once again, you have two sides and one angle, but look at, we have side A, side C, and angle B. I call this non-matching because none of the letters are the same. We have A, C, B. We're over here, two sides and an angle, but we have side A, side B, and angle A. You can see one of the sides and the angle are the same letter. The reason that's important is because for matching, we're going to use law of sines. For non-matching, law of cosines. Now, if you can't remember, once again, if you tried to take this example and you said, well, let me go use the law of cosines, it would not work. You would quickly see that I can't solve it. So you would go back and say, well, it must be law of sines. Or if you took this information and said, let me go use this information and use law of sines to solve it, you would get stuck. You can't do it. You have to use law of cosines. Of course, anything you do in math, if you sort of know the rules before you do it, then you don't have to spend your time trying something that's not going to work. So this is not that hard to remember. One angle, two sides, the matching, law of sines, non-matching, law of cosines. Let's do the matching part. Now this can be a little tricky because, as it turns out, when they give you the information, there are three things that can happen. We can use law of sines in a minute, and when we're all done, it will turn out that we'll have the information for the triangle, just one triangle. In other words, here we'd have to find side C, and here we have to find angle B and C, one triangle. However, sometimes you'll be given this information and you'll go off and you'll try and use the law of sines, and as you use it and you do it correctly, you find out all of a sudden you're using your calculator to crunch a number and you're going to get an error. Well, you've worked it correctly. Sometimes that happens. When you're doing the math, you cannot get an answer. And as it turns out, what happens is there's actually no triangle. Even though they've given you, they tell you there's two sides at an angle, and they want you to figure out the rest of the triangle. It's like, sorry, it's impossible to have a triangle with this information. Maybe they're trying to trick you, maybe they did it on purpose. But there's actually no triangle that's possible with. Now, I'm not saying this example is like this. I'm saying we're going to have examples where they give us information and you begin to do the math and you see that there's no triangle. And what's really sort of crazy is sometimes they give you information and there are actually two possible answers. There are two different triangles that have the same A, B, and this angle A. Now what's interesting is I brought the textbook along to sort of show you, maybe you can see it here. Here's an example where they give you side B, angle A, and we'll call this side, this is like side C, I guess, because here's B and A. No. They give you side B, angle A, and side A. And look at what's happened. Side A, so I can focus. Side A is too short. It doesn't even make a triangle. It's not long enough. And in this case, if you try and do the math on your calculator, you're going to get something that says error. This is the no triangle case. They've given you information that doesn't really make up actually a triangle. Now here's an example. Let's look at this example here. So once again, they give you side B, they give you angle A, and they give you length A, but you know what? Here's the length of A. There's two different ways we can connect A to side B. I could put it like this, and therefore this bottom here is my side C. Or if I wanted to, for some reason, I decided, well, let's just do my side A from here to here. Like the question is, which one of these triangles is correct? You've got one triangle like this and one like this. Well, neither one of them are correct. They're both possible. This is the case where actually you get two triangles. In other words, for the information they give you, you can go and create two different triangles. So far we've talked about information they give you where you can't make a triangle at all. Sometimes the information you're given, you can create two different triangles. Now here's an example where they give you side B, angle A, and look at side A. Super long. You can see we can form this triangle, but if I were to try and take side A and sort of move a different angle and make another triangle, I could not do it because side A is way too long. Here, when this was side A, I could form a triangle like this, and I could take my side A and just change the angle, and I could form a second triangle. With this one, I cannot form a second triangle. So this is an example of you just have one triangle. So this shows you how no triangle, one triangle, two triangle. Now how can we figure that out mathematically? Well, we have to use the law of sines, and it can be a little tricky. It's actually just a fair amount of work, because what we have to do is we're going to go use law of sines to figure out a triangle. And if we get a triangle, we then have to go ahead and see, hey, is it possible that we have a second triangle? And it may or may not be, but you have to go ahead and try and determine it. So let's go ahead and use this example right here. Side A is 3, side B is 2, angle A is 50. Because it's matching, I'm going to use the law of sines, and you notice here I have A, and B. So hopefully it's pretty obvious that we're going to say law of sine. Sine angle A over A, sine angle B over B. Let's plug in what we know. I know A is 50. Sine of 50 degrees over side A, which is 3, equals, I don't know B, over B, which is 2. So here's what I have, and now you notice the only thing I don't know is sine B, so I can calculate sine B. It's going to be 2 divided by 3 times sine 50 degrees. So grab my calculator. Sine of 50 degrees times 2 divided by 3. 0. I'll round off. So basically sine B equals 0.511. But what I really want, I don't want sine B. I want to know what angle B is. How do I figure that out? Now this goes back to something we learned a while ago in trig, where I said, well, how about if we take the inverse sine of both sides? The inverse sine of the sine just leaves what's inside. So in this case, the angle B is the inverse sine of 0.511. So 0.511. So you have a key on your calculator that's inverse sine. Make sure it's in degrees. I'm going to round this to 1 decimal. I've now determined that angle B is 30.7 degrees. This is sort of messy. Let's review what I know so far. I know side A was 3. Side B is 2. I don't know side C. Angle A, I was given angle A. Angle B, I just determined to be 30.7 degrees. I need to figure out angle C. Now I'm going to go ahead and finish this triangle. Although in this case, I know there might be a second triangle. But let me just finish out this first triangle, and then I'll go see if there's a second triangle. So the way to finish this first triangle, first of all, I know 2 angles. How can I get the third angle? Well, I just take 180 degrees minus these two angles, right? So 180 minus 50 minus 30.7. Looks like angle C is 99.3 degrees. The only thing that's left is side C. Let's just go ahead and use another law of sines to figure out the length of side C. So if you want to, I'll just maybe do A and C. So you saw law of sines, sine A over A equals sine C over C. Sine A is sine 50 degrees, and A is 3. Sine C is 99.3 degrees, and we don't know side C. So if I rearrange, move things around, I end up with side C equals 3 times sine 99.3 degrees over the sine of 50 degrees. Then you grab your calculator. Sine divided by 50 sine equals times 3 equals, looks like 3.86. So if I go back here, so now I've figured out everything. So there's at least one triangle. But the key is, whenever we have one angle, two sides, and it's matching, where we use law of sines, if you get one triangle, you have to go check the second triangle. Now here's the key. Let's go back and look at what we did when we did the first triangle. Very first thing we did, because we were given side A, side B, angle A, the thing that we were able to determine right away is angle B, right? And that's the first thing we did here. And after we found angle B, we went ahead and found the rest of the triangle. What I have to do, I have to go back. In this case, the very first angle you calculate is the one you want to use. And what I'm going to do is, B is 30.7. Here is the way I check to see if there's possibly a second triangle. For the second triangle, I'm going to put a little dash up at the top. So this means this is angle B of my second triangle. Angle B of my second triangle, if it does exist, is simply 180 degrees minus my original angle B. Why am I doing B? Because B is the first angle I calculated when I began this problem. So it's always the first angle you calculate is the one you're going to take. I found B to be 30.7 degrees. So what I'm saying is, potentially, here's the new angle B for my second triangle. 180 minus 30.7. So once again, let's review what we've done. We used law of sines to calculate the first triangle. Very first thing we did, the one thing we could do, was we found angle B to be 30.7. We went ahead, finished that triangle. But then I go back and I grab this piece of information and say, okay, if I have a second triangle, the angle B of that second triangle is going to be 180 minus the initial B. And here's what the new angle B would be. But it's not a for sure thing yet. So far, we were given that A is 50 degrees. We calculated B, I'll call it B prime, is 149.3 degrees. And now, if this was angle A and this was angle B of my new triangle, what would angle C of the new triangle be? Well, we know you take 180 degrees minus angle A minus angle B. So we're going to grab my calculator and say 180 minus 50 minus 149.3. And then you say my angle C of my second possible triangle is negative 19.3 degrees. Now we cannot have an angle with a negative degree. So what does that tell me? That says, you know what? In this case, there's no second triangle there's actually only one triangle, and then the easiest thing is just go back. I don't know where I set that sheet. Oh, here it is. You go back and you say, here's my one triangle. So let's review that. One angle, two sides, matching. I got a side A and angle A. Law of sines gave me a triangle, but I always have to check to see if there's a second triangle. How do you do that? The very first calculation we did with my first triangle was to determine angle B. You take that piece of information and you say, okay, I'm going to take 180 degrees minus the angle B from my first triangle, and I'm going to say, therefore, if I have a second triangle, this is going to be the new angle B for the second triangle, 149.3 degrees. But then you say, okay, I was given angle A, I'm proposing another triangle with this angle B. What would angle C be if you had these two angles part of a triangle? So we determine angle C would be negative 19.3 degrees. And since you can't have a negative angle, then we stop and say there's only one triangle. All right. I know that can be a little confusing. Let's do another example and see what we can find. All right, how about this one? Side A is 4, side B is 5, and angle A 60 degrees. So what do we have here? We have two sides and one angle, and actually this is matching because we got side A and angle A. Because of that, we're going to use law of sines and see if we can figure out the first triangle. So law of sines says sine of big A over A, in this case I'm going to do B, I plug in everything we know. Sine A, sine 60 degrees. The length of A is 4. Sine B, I don't know. All right, so here's an equation to figure out angle B. So 5/4 times sine of 60 degrees. So 60 sine is 5 divided by 4. Let's go 1.0825 just to make it 1.08. Now B, of course, would be the inverse sine 1.0825. You know what I get on my calculator? Error. Now when you get something like that, you need to go back and check your math to make sure you didn't mess up. But if I would go check, I actually did not mess up, so this is right. So what this says, this is a case where they've really given me sort of bogus information. There actually is no triangle. You can't take a side of 4, a side of 5, and this angle 60 and create a triangle. No triangle. Now, I'm going to do one more problem where I have two sides of an angle. Let me go ahead and do that on the next video, and we'll pick up